Okay. In this video, we will be seeing about the insertion at this specific position in singly linked list. It is a key operation that you must understand deeply when working with dynamic data structure. Okay. Here we will cover how it works, the algorithm step by step, and a code, how we want to code, and common mistakes to avoid while inserting at the middle or specific position, and finally a few real life application of this operation. Okay. First one is we can see what is a singly linked list. A singly linked list is a collection of nodes. Each node contains of two parts. First one is data, the data where we store this, where the value is stored, and next is a pointer to the next node. Okay. Insertion at specific position means placing a new node between two existing nodes. Consider if there is a node containing data value 10 and there is a node containing data value 20, and we, in insertion in the middle position is nothing but inserting a new node has a data value of 15 in between the node containing 10 and node containing 20. Okay. What is position based insertion? Okay. Position based insertion means inserting the new node at the given index or position in the list. Position 1 means inserting at the beginning. We have already seen that. Position length plus 1 means inserting at the end, which is nothing but we are going to insert a new node at its end, which is nothing, insertion at the end. Position k means inserting between k to 1 and kth node. To perform this, we must traverse the list up to k minus 1 node and adjust the link carefully. Here are the detailed steps for inserting a node positions. Which is, first one is we have to create a node. Okay, check for edge cases. Okay, if the position is 1, treat it like insertion at the beginning, and if the list is empty and position is not 1, it is invalid, we cannot insert in the middle. Okay, traverse the list up to the position which if suppose the position which we want to insert is 4, we have to traverse till 3. Okay. Update the pointer. So set new node of next to the pointer of current next, and set current next to the new node. Okay. If suppose there is a node which contain head node as 10, next node 20, third node 30, and finally null, and we want to insert a node 25 in the third position, which is nothing but in between 20 and 30. Traverse to the second node with the value 20, create a new node with data 25, set new node next to the current next, and set current next to the new node. Okay, finally what will happen is we will be inserting the node 25 in between 20 and 30. Okay, I think you can visualize that. Okay, we can see the pseudocode for that. Here is the pseudocode which is displayed here. Okay, you can refer this. Okay, when writing code, don't forget to handle this scenarios. First one is invalid position. Inserting at position 5 in the list of 3 nodes, it is not possible. Okay, empty list. If the list is empty, it is not possible to insert a node in a specific position. Okay, boundary position like inserting at the head or tail, it is simply insertion at the beginning or insertion at the end. And memory allocation failure, it may happen in real world system. Debugging become much easier if these are handled properly. If we see this and if we write pseudocode according to this, it will be easy for us to handle the bugs. Okay, application. When coming to application, we can see this in music playlist, adding a song at a specific position. You can visualize that. Okay, to add list application, to do list applications. Okay, list apps like inserting a new task in between two other, and in operating system managing process queue when prioritize defined positions, and in dynamic forms inserting field based on user selection, and version control managing nodes in a change history chain, and anywhere dynamic ordered data is managed, position based insertion comes into the play. Okay, insertion at a specific position involves pointer manipulation and careful traversal. Always validate the position and handle edge case. This operation is powerful and widely used in dynamic system. Thank you for watching the video. Hope you understand this concept. Thank you.